Okay, so this is number 15. And so we didn't do this one in class, but I'll do it now so you can take a look. It's got relatively few numbers in it, so that'll make it certainly easier. Um, I'm not sure what kind of a polynomial this is, so I might take a look. I want to make sure that when I'm trying to figure that out, those are consistent, 5 and 5. But when I check this, let's see, I'm adding 9 there, but when I check that, that's 49. And I can't go any further using common differences because I'm out of numbers to use. What I know is that it's not a linear equation, and so if it's growth, I think I'll probably just go ahead and try quadratic and just see what r is. Remember, we're going to make 1990 into year 0, and 1995 into year 5, and 2000 into year 10. Okay, and so I went ahead and I put the numbers in. You go stat and you edit. So you hit enter, and there are your numbers. Just type those in. I don't think you need help typing numbers in. Okay, just make sure they match up. Then if I think it's quadratic, well, I'll go to stat, calculate. Quadratic regression is number 5. So you just hit a 5 and enter. And so it's saying 0.8, negative 2.2, and 149. It's got r squared is 1. That's telling me that it's a perfect fit to quadratic. 3 points is enough to determine a quadratic equation. And so that looks pretty good. And so my equation would be 0.8x squared, negative 2.2. So 0.8x squared minus 2.2x, is it plus 149? Is that right? Okay, and so that's what I put in y1. Now you could certainly type those numbers straight into y1, but I'm going to go ahead and show you the way of automatically inserting it just to remind you of how to do it. Okay, and so I'm going to go to y equals. I've got that other equation that had tons of numbers. Just clear that out. Okay, I always just clear it out. I'm going to vars. Right? Remember, I started at y equals, and then I go to vars. Okay, I want statistics, which is number 5. I've got to shift over to equation, so it's right arrow, and then enter. Regression equation, number 1 is the one you want. And it puts it in there for me. And now I can go and verify by going to my table, which is second graph. That's my table. 149, 158, 207. Fits perfectly. Remember, I've got it jumping by 5s up here because I went to second table set, and I set my delta table right here at 5, and I started table start at 0. So delta table, that little triangle table, means how much it jumps each time. Certainly you could just change automatic to ask and type the numbers in that you want. I think one of the things that a lot of students are going to forget is to change the years from 1990 to 0 and 1995 to 5, etc. So now when I go back to table, okay, I've got to remember that's not year 0, that's 1990. So 1995, 2000, 2005 is 296. So I might say, what is it in 2005? And it would be 296, right? Is that what it said? 296, okay? And that's it. And the process is basically the same. If the r value you get isn't 1, 1 is a perfect fit, right? That's telling me that that equation fits the data perfectly. If it's different than 1, then you might try a different version, a different type of polynomial, cubic or quartic. It's going to be one of those 4: linear, quadratic, cubic, or quartic, and see if it works better. Okay, the process really isn't that long. I mean, once you've got the data in, you're talking about stat, calculate, pick your regression equation, hit enter. I know some of your calculators have another step in there, but once you get those things set, list 1, list 2, just scroll down to calculate and hit enter. Okay, and so I know you don't have your calculator at home, but this is what you'll be seeing tomorrow.